We're honoured to welcome back Carsten Kraus, a visionary at the forefront of artificial intelligence. It's been a year since we last spoke with Carsten, and the AI landscape has evolved significantly. Carsten has been at the heart of this transformation. His work is not just about advancing technology, it's about shaping a future where AI amplifies human potential.
So Carsten, thanks so much for being here. A lot has happened since you talked to Lisa right here at this very venue a year ago. One of the things that you talked to Lisa about last year was foundation models, right? And the importance of foundation models. And clearly in 2023, we saw amazing capabilities delivered by massive frontier models. So what I'd love for you to comment on is, how do you see the emergence of small language models occurring this year, right? How do you think that's going to happen? Do you think it'll be dominated by a couple of permutations of Mistral, or do you think it's going to be more widespread if it happens at all? I'd love your perspective on that.
Yeah, let me please first comment on LLMs. LLMs have had a tremendous effect on the industry, and the industry, all industries will wake up now to this new emergence. The thing is, people said that AI is the new electricity. It will be everywhere, and that's true, of course. But the new thing is, LLMs are the new electromotor. So what's the difference? AI is difficult as electricity was. So at the time when electricity came up, it had so many uses. Like, how do you know about electrolyzers? It took 40 years to build the first light bulb. Adam was just the last one to finish it. But when you have a motor, every engineer knows how to automate what you can do with a motor. Every engineer can implement it in their own machinery, and so the motor is the new moment for technology, and the LM is similarly the motor for using AI.
It's essentially the electromotor.
Yeah, so it's essentially something simple that everybody understands from the outside. You don't have to know how the motor works.
And I also don't need to know how electricity works.
Right.
In order to use the electromotor.
You just have to know that when you put electricity to it, the motor turns, right, and it will drive something. And the same goes with LLMs. So it's very, very complicated on the inside, but using it is simple.
Yeah, they're massive, they're complicated. Right. They cost a fortune to train and a lot of time as well. Yeah.
But using them and also including them via the API into your own programs is quite simple.
Yeah, that makes sense. So how do you see this applying to the turn to small language models? Do you think that'll be a rapid change, or how do you think that's going to emerge?
Yeah, the small language models of today are much more powerful than small language models like GPT-2 before.
Right.
Because they are trained with large language models in the background. So you can kind of distill the knowledge of a large language model into a smaller language model by building synthetic data and so on. And so right now you have models which are still difficult to train because you need the big model behind.
Right.
But you have the small model where the inference, the usage of it is very cheap. When you had the motor in such a size and you suddenly have it this size, you can do so many more things because suddenly it's cheap, it's easy to implement, it doesn't require so much hardware around, you can do it on the phone, on our computer and so on. And this will change the game again dramatically.
Yeah. I mean, we're already seeing models that are just 1 billion or 2 parameters.
Right.
It's they not only run on a laptop, but like you said, I mean, we're seeing them to be small enough that they will fit on a phone, so they can do inference on a phone.
Yeah, they do.
Yeah, that's a big moment.
Yeah.
Do you think the market will be dominated by just a couple of, Mistrals, or do you think it's going to be more widespread? Are we going to see a lot of other types of models from other companies emerge?
So as of now, you have to have a larger model in the background to build a small large language model.
Right.
And
the small version of the large language model.
Right. So you need to have access to that. But I mean, you could use something like open source, open weights Llama, which is a medium-sized LLM, and train smaller models from that. But of course, still companies who have access to bigger and stronger models have advantages also to train smaller models.
Right.
So let's see what happens there. What I expect is that also some fine-tuning of the smaller models will happen.
Yes.
And probably people will build a lot of things around the small model to run it. The small models of today are already very, very powerful. So like there was this Phi 2 Microsoft.
By Microsoft, yeah.
Right.
Only 2.7 billion parameters or so, if I recall.
I think even less, yeah, so below 2. V2 with has capabilities which are approximately as good as Llama 70B. And that's a huge difference. It's like 25, 30 something times the difference, yeah. So, and that's a very, very strong advantage in inference time. You can use this on your phone, but also if you run it on your servers, it will be faster, it will consume less compute, and thus it makes it cheap enough to integrate into almost every application.
Right. And I would expect that we'll see in the small language model space, we'll see not only domain-specific fine-tuning, but also task-specific fine-tuning done on some of these small models. So there'll be multiple stages potentially of different types of fine-tuning in order to really surgically deliver on a specific use case.
Yeah, also fine-tuning a large language model is not as easy as fine-tuning a vision model. So an object detector or so, but still more and more people come up who understand how to do it, and also the methodology of fine-tuning will evolve and will be easier for many companies.
I think that will mature a lot this year, right? That will become more standard practice, and it'll be a much more predictable pipeline, if you will. Yeah, that makes sense. Yeah. Let's go to reinforcement learning. I know you have a passion and a history with not just AI, but AI with gaming, right?
Especially Go. I'm a Go player.
Oh, and you're a Go player yourself. Okay, I don't feel like I'm smart enough to play Go, but that's good for you. So reinforcement learning had this amazing moment based on, I think it became part of the public consciousness when DeepMind published some of their research around training agents based on originally Atari simulations, right?
Oh yes, originally, yes, yeah. That impressed me already, and later on came the Go thing where nobody expected it to happen.
Yeah, AlphaGo and then AlphaZero later. Amazing moments. So my question for you is, a lot of people think that RL has already had its day. RL obviously, conspicuously has challenges around complexity, but also sample inefficiency. So my question for you is, do you think it indeed is a thing of the past, or do you think we're going to see a resurgence in reinforcement learning, right? Will there be a new day for reinforcement learning in the future?
Yeah, so the difference between LLMs and deep reinforcement learning is that deep reinforcement learning is not the simple motor. It's rather like a fusion reactor or something.
Right.
It's really a difficult thing to do
much more complex.
To do at all and to do well. So much more complex right now, right? And so applications will not sprout as they do with LLMs.
Yeah.
Unless we find some combination, something that is easy enough that people can use the power of deep RL also in combination with other models. But it's not over, and deep RL is probably going to surprise us in many more ways. When we had this Go thing, everybody said, wow, that's impressive, but are there any practical uses? And suddenly you had AlphaFold, and medicine has changed.
That's a great example. Right.
Yeah, and they have done very impressive things in the meantime, which have not gained the public, not so many publications in the meantime. So, they improved matrix multiplication. So that's a very important general math technology to run any kind of neural network. You need matrix multiplication to run
obviously
neural networks. Yeah. So, and they improved it to make matrix multiplication faster than all the scientists did before. Then the next thing is they have just found, just before Christmas, Google has discovered 300,000 more crystalline materials, which are stable and can be synthesized.
Yeah.
So and that's something that would have taken decades to do with traditional computing, and with deep reinforcement learning, they suddenly could do those things because the computer found strategies to do this.
Right.
Yeah. So, and I assume that if you combine these things one day, so I think Google is probably working on the combination of LLM and deep RL. So you have like an LLM expert that knows how to handle the deep RL.
Right.
Suddenly it will open to many other applications like business strategies or anything else. The thing is, you need to have data, not actually data, but the possibility to experiment. So it cannot be applied to everything.
Yeah, clearly a super important part of at least reinforcement learning agent training in the past has been having a high enough fidelity simulation of whatever it is you want to study, right, and automate. So that's been a constraint, obviously, in many.
But like the fusion reactor, which I mentioned before, the fusion reactor is something when you have a very good physics model, you could probably use DeepRL to optimize, for example, accelerators.
And work was done in that space, wasn't it? Was it Google or was it DeepMind that did?
No, there are several
paper.
startups. There are startups. Maybe there's also a paper by other people, like Google also. But for example, there is Proxima Fusion in Germany, who use physics-enforced networks on the background to optimize the stellarator magnetic field. But it's not DeepRL. It's something different. But
something else, okay.
But with DeepRL in combination, where you have these physics-informed networks, you can do probably a lot more, and you can find optimal settings much more quickly than you can without.
Again, though, tightly coupled to the importance of the simulation environment, right?
Yes, yeah.
Coupled to this high-fidelity representation based on, in this case, based on first principles, right, of the world.
Yeah, you need to have the possibility for the model to experiment.
You're right.
Math, like mathematical multiplication, math can always be simulated because math is just a concept.
Yeah.
But with reality, like physics, it's more complicated.
Yeah. Well, and here, Jan LeCun famously talked about the sample intensity of some of these environments where the agent must practice, thousands and thousands, if not millions. Of episodes in order to learn how to not drive off a cliff or something. Right. So you need a good simulator for that, and you need a lot of samples. So
exactly. So, but I expect a strong future for DeepRL, and if it finds this way into a more simple use, I think it can also change the world tremendously.
Yeah. I look forward to that day. I look forward to the day when some of these reinforcement learning use cases are more accessible, right? I mean, today a lot of them come out of DeepMind, and I think it would be great to see them. Yeah, exactly. Most of them do. And it'd be great to see them come out of more pedestrian organizations.
Yeah.
So, I would love to talk a little bit more about kind of the opportunity that exists in more generally in the AI space. I mean, you have a long, impressive history of being an entrepreneur. And so my question is, where do you see opportunity in what has become a pretty crowded AI startup space? And I guess I would say a corollary to that is, where do you see the surface area being where there's still a lot of opportunity for innovation?
I think everywhere, but not in the breadth that it happens now or in the density. So because last year, like everybody and their dog suddenly could use AI to do something that nobody thought of before by just prompting the LLM. But of course, once you show this, somebody else can copy it and just also prompt the LLM.
Build upon it and do other things.
Yeah, so you have a great idea what to do, and suddenly it's so easy to realize it. But once somebody else sees your idea because you publish the software, then other people say, I can do the same, maybe better. And they start prompting because it's not deep knowledge these people have. They just have a great idea. Yeah. But ideas cannot be patented. Only technologies can be patented. You can get a patent for that. So they don't have a big, what we, as an investor, I call it the moat.
Right.
And you need to have this moat in order to keep competitors at a distance. But of course, there are so many challenges in the world still unsolved, and many of them can be solved with AI technologies, and some probably with AI technologies that don't exist yet. So I think there is still a lot of space for those people who really understand AI deeply and build their next AI startup. This is not the average prompt engineer. Right. It may be that you combine also the LLM and some prompting with your other technology, but you have to do more than just prompting.
So what I think I hear you saying is that by being able to build upon these capabilities, a lot of the innovation will end up being domain specific, where you target some of this innovation to solving specific problems in specific areas. Is that a fair interpretation of what you were talking about?
Partly yes, partly no. So let me start with the yes. So Andrew Ng says that now with the emergence of LLMs and this easy adaptability of AI to your specific needs, many small companies will come up which solve a problem which has only a market of maybe 2 million per year. And of course, he's right in that aspect too. So what I said before about the prompt engineers is not completely right, because you can still build a business on that if you just do something very niche.
Extremely well for a small, even if it's for a smaller audience, do it really, really well.
So and that is very domain specific. Then of course, the next thing is when you develop some things with some domain knowledge. So like you have access to data nobody else has. Then you can also build a startup which has some distance to the competitors. Even if they see it, they cannot copy it because they don't have access to this data or to the other technology you combine with the LLM.
Okay.
So the development of new AI technologies, so new core technologies and new difficult findings is something that is probably too expensive for these very small niches. So when you take a look at this Casablanca.AI, we put in about 2 million research without external funding. So, and of course that targets a market of 550 million video call users, and so you have a huge market in the end. But if you would do it only for a small niche, it would not be worth taking the risk now.
Certainly. Okay. But even for organizations that are much smaller than yours, than Casablanca.AI, being able to use some of these impressive, powerful technologies as building blocks allows them to justify economically targeting, a much smaller group in a more surgical way.
Yeah. When you use the building blocks, then of course you can do smaller, with less effort, you can target something. And it can also be a huge market, but if you use building blocks, it means that you don't have so much own technology. And it might not be that you have this moat that protects you from the competitors. So with Casablanca, we have developed so much own technology. We're currently building the 6th patent. It's a different thing. So,
but you have to invest more to build your moat. You have to invest more in order to defend your space.
So, but there's more specific or more technology that does something very specific that can find a big market, I'm quite sure. So probably you can do things also in the environmental space, in the chemistry, in medicine, and so on, which does not completely rely on building blocks, but has some own technology to it.
That makes sense.
I don't know which one exactly now for each topic.
Right. Well, it starts to get very specialized.
But AI is big enough, and the problems of the world are big enough that it's worth doing something.
I just talked with a woman today that founded NeuroPen, and she has a very specialized service that serves radiologists that takes MRIs and uploads them to a SaaS service, and over time, it analyzes, using convolutional neural networks, it analyzes this imagery to detect changes, to the MRIs in order to support the ability for radiologists to provide better care, to their patients. And so very, very narrow, very surgical, application, obviously, of some of this technology, but, an opportunity to have a really amazing positive impact.
Yeah, but the domain expertise here is a differentiator, so not everybody could copy it. Even though probably the AI she uses, the general technology behind it is just building blocks.
Right.
But she knows how to combine those those building blocks for the things she is doing, and she perfectly understands what she's doing in neuroimagery and radiology. And most people do not understand radiology, so it's also some kind of mode.
That makes good sense. So I have one last question for you, and it's a selfish one. Okay. I know some of the work you had done in the past was around technology for travel. Like more than 10 years ago, you delivered what was essentially meaning-based search at the time. So very exciting. So I'm going on vacation later this year to Positano, Italy. So
beautiful.
Any recommendations on where I should stay?
So for one thing, very good choice. The Amalfi Coast is one of the most beautiful places I've seen in the world. Unfortunately,
that's why I'm going.
I didn't stay in Positano myself. If you start your trip in Naples,
we'll fly into Naples.
And we stayed in Naples at Palazzo Caricciolo, I think it was called. And that's a beautiful, not so well-known hotel with a very nice inner court, delicious food.
It's Italy, of course.
Huge rooms and all very well restored and renovated. So I very much like the stay. We stayed there twice. So on the way forth And then because we liked it so much on the way back, we took one night to there.
Okay, well, there you go. This was worth it just from that. So I appreciate it. All right. Well, thanks again for being with us again this year. I hope to see you again next year. And I expect and hope that a lot more will have changed, and we'll be able to reflect on all the interesting innovations that we've observed over the course of the year. So
thank you very much.
All right. Thanks again for your time.
Bye.